Harrison, a student in Miss Moran's class. This is my 6th grade science project. I had lots of fun making this, and I really hope you enjoy. Now, let's start with our moon, which is the biggest nor the smallest moon in our solar system. And our moon makes a complete orbit in 27 days and rotates at the same rate as our Earth. And the moon is a rocky solid surface pitted with impacts, which is why I made the impacts black, because most of them are really deep. But if you go around one side, it is very flat because that's the side that's always faced towards Earth. And it's always facing Earth because it rotates the same rate as Earth. And the moon has a very weak and thin atmosphere called an exosphere, which is an atmosphere that is basically you know how the Earth's surface is basically entirely dust? Well, basically the atmosphere, the exosphere, as I should say, is as thin as dust, and that's not good for supporting life and water, because then all the water would freeze up, and that means no life would grow, and no life. And more than 100 spacecraft have been launched to visit the moon. Now, this surprised me when I found this out on the NASA website, because it takes a lot, and I mean a lot, of rocket fuel just to send it up to the moon. Now, imagine when we get to like all the other planets. Imagine how much rocket fuel that would take. And the more fuel things that you put, the more fuel it takes to actually put it up. So no matter what, it will always go to the same planet, no matter how many fuel canisters you have on it. He is also the only celestial body beyond Earth that has been visited by humans, due to the fact that all the other planets have too much, that are too far away, and it requires too much rocket fuel. And as I said, the more fuel you add onto a rocket, the more weight, which means the more rockets, which means the more fuel being burned. And that's really expensive too, so I do not. So if I could, I would definitely not take a trip to any other planets. Phobos is the next moon, which is right here. Look at this beauty. Well, it's not really beautiful due to the fact that it's gorged with meteor impacts. It is coming towards Mars 1.8 meters every 100 years, which means it's either gonna crash into Mars, like it's gonna be a gigantic explosion and possibly destroy Mars, or it will turn into millions of dust and transform into a ring around Mars, which means basically a mini version of Saturn. Yeah. And it is made of a C-type rock that comes from C-type asteroids. And I will talk about that later when we get to the asteroids. It was nearly shattered by a giant impact crater, which made it look like an asteroid, and that's why scientists think it's an asteroid. And it has no atmosphere due to the fact why scientists think it is an asteroid. Sorry about that. It is covered with a very fine dust which leads to avalanches on its surface. Which, if you want to build a house there, you can't. The dust, you can't even put anything on it. It's basically like quicksand. And it was discovered on August 17th, 1877 by Asaph Hall, which is an astronomer. Io, which is this beauty over here. Well, it does look kind of good, to tell the truth, but if you go on it, it's not really that beautiful. because it is filled with lava. And that orange ring around it, well, it's not around it, it's on it, that's all lava. And the surface, which is this green stuff right here, that's the surface, and that is all paper thin. No way you can do anything on that. It is a bit larger than our moon, though, which is the reason why it's not the biggest. Our moon is not the biggest or the smallest. And it is also the 5th one in distance from its planet, which is Jupiter. And it's also the 3rd largest of Jupiter's moons. Io has an irregularly elliptical orbit, which, because of that, it causes Io's surface to bulge up and down by as much as 100 miles. Now, those bulges say sometimes, you know how you have a zip, pop, they pop, which puts lava, which makes these holes right here. You see them? And those are holes made by the either mirror impacts or pops on the surface, and then the lava fills into that though and creates new land, which is also the reason how it's so irregularly flat. It's so flat, and it's also. And the tidal sequence inside the Earth, inside the surface, it pumps tremendous heat inside of Io, which, keeping as much of the crust in liquid form, which means the reason why it's paper thin, and then they seek any available escape route, which is the bulges, to relieve the pressure. And thus, the surface of Io is constantly renewing itself, which is why it's so flat, and filling in any impact craters with molten lava lakes and spraying smooth new floodplains of liquid rock. It was discovered on January 8th by 1610 by Galileo Galilei. We might hear him a few times in this. Because he discovered a lot of moons. Mimas, the next one. He's Saturn's moon. Well, it basically looks like a Death Star, as you can see, which is also the way out how the Death Star got. Well, it was discovered on September 17, 1789 by an astronomer, William Herschel. Mimas has a crater so large that on one side that it is almost split in half, and it makes it look like the Death Star from Star Wars. As I said, it takes 23 hours for Mimas to complete an orbit around Saturn, which is actually pretty short. It's a little bit under a day, Mimas, it is made of solid ice, which confused scientists because Mimas is close to Saturn, whose moon is much harder than Mimas. So Mimas should be melting back into water, but it's not, and probably why I said it makes no sense. The moon is very fast, and its orbit is a bit big, so it should have inner heating, which could melt itself into water. This concept started the Mimas test, which states that any theory that claims to explain the partially-thawed water for the Enceladus, which is behind Mimas, which is what I was talking about, must also explain the entirely frozen water of Mimas. Now, moving on to Cordelia. Now, this is one of the 2 shepherd moons that keep Uranus's epsilon rings into dispersing into outer space. Now, before I continue, shepherd moons. The planets that have rings have shepherd moons that keep those from keep the rings from dispersing into space. Now, it was discovered on January 20th, 1986. It was discovered by the Voyager 2 NASA team. It is mostly made of a carbon-rich material that comes from Class C asteroids in the asteroid belt. Its original name was S19 086, 7. Cordelia was named for one of the youngest daughters of King Lear in the William Shakespeare play of the same name. The moons of Uranus are named for the characters in William Shakespeare's plays and Alexander Pope's Rape of the Lock. Well, I don't know what neither of the plays are, so I really can't explain anything about it. That is closest to the planet than any other moons of Uranus. Triton is the largest of Neptune's 13 moons, and it has a retrograde orbit. Right there, Triton. And which means that it orbits in the opposite direction of Neptune's rotation. Scientists think it's a dwarf planet that was captured by Neptune's gravity millions of years ago because it shares many of the similarities with Pluto. Yes. The best known world of the Kuiper Belt. Triton is locked in significant relation with Neptune. One side faces the planet at all times, but because of its unusual orbital inclination, both polar regions take turn facing the sun. Triton was discovered on October 10th, 1846 by an astronomer William Lassell. Now this is what confused me. I didn't find any facts about it on NASA. Why is there a blue strip? I was wondering, because when I was painting this, I saw there's a faint little blue strip. I made it darker to show. I'm wondering, what is that? So probably we'll find out later when our technology becomes better. Charon, which is over here. Now, Charon has a different surface composition and structure than its home planet, Pluto. Charon's orbit takes 6.4 days to orbit around Pluto. Charon either rises or sets or hovers on the same spot on Pluto's surface. This is called tidal lock. And if we do this same thing to our moon, what would happen is our tides will be locked in the same thing. So when the moon starts tidal locking and the tides are high, it would keep doing high tides. And there would be no way to control it. That's basically what it means. And the orbit of Charon is tipped like Uranus. So it's basically a mini Uranus. And Charon was discovered in 1978 when an astronomer noticed that Pluto seemed to keep growing and shrinking. Charon is almost half the size of Pluto. It is so big that some people refer to them as a double dwarf planet system, which means they think it's two dwarf planets. Now, we're moving on to dwarf planets. They are these miniature planets. They're smaller than any moons here. And they still have an atmosphere, and they're even smaller than Phobos, which confused scientists because Phobos has no atmosphere, but dwarf planets do. Pluto was discovered in 1930. Pluto was long considered our solar system's ninth planet, which it was surprising at the time. But after the discovery of similar intriguing worlds deeper in the distant Kuiper Belt, which we will talk about later, the icy Pluto was reclassified as a dwarf planet, which sadly made it so we don't have a ninth planet. We only have 8. The new class of worlds may offer some of the best evidence about the origins of our solar system, because Kuiper Belt is basically, well, I'll talk about it later, as I said. And one day on Pluto takes 153 hours, which that means how much time it takes for Pluto to spin once, and it takes 248 years. 248 years. Let that sink in. To orbit around the sun. It is thought that Pluto has a rocky core surrounded by a mantle of water ice, with other ices coating its surface. Pluto has five known moons. Pluto is sometimes called a double planet system due to the fact that its moon Charon, like I said before, is quite large and orbits close to its distant planet. Now we're talking about the Kuiper Belt, which I mentioned a lot, and I mean a lot in Pluto, because that's its home place. Kuiper Belt is a disc-shaped region of icy objects beyond the orbit of Neptune. Now, before I continue again, it is basically all the basic materials from the making of our solar system. This is all the remaining materials, apart from the asteroids. This is the only parts that are not in the asteroid belt, and beyond the orbit of Neptune. Pluto and Eris are the best known of these icy worlds. And Eris, I'm not talking about right now. So there may be hundreds more of these icy dwarf planets out there. The Kuiper Belt is the home for all the comets, which I will talk about later. That's the last thing we'll be talking about. That orbit our solar system. The Kuiper Belt is a region of space. Like I said, it's a region of space that has all of our... You get it. The Kuiper Belt is a donut-shaped ring around our sun. Some dwarf planets have thin atmospheres that collapse when their orbit carries them farthest from the sun. Yes. Sadly, that means the planets almost get destroyed. Asteroid belts. Here's an example of an asteroid in the asteroid belt. Asteroids are rocky, airless worlds that orbit our sun, but are too small to be considered to be called planets, or dwarf planets, to say. Tens of thousands of these minor planets are gathered in the main asteroid belt. A vast donut-shaped ring, like the Kuiper Belt, as you can see in the diagram in the Kuiper Belt too. This acts as a double diagram. And between the orbits of Mars and Jupiter. Saturn also, it wasn't in the sheet. It's all Saturn also controls the donut-shaped ring, which is also why Saturn has most of all the rings. You probably were wondering, how does Saturn have most of the rings? Asteroid belt. And asteroids that pass close to Earth are called near-Earth objects, which is actually kind of endangering, because if you move them over a little bit, they could come, going back to Earth and our moon, they could go crashing into our Earth and possibly destroy our Earth like the dinosaurs. Now, if all the asteroids were combined into a ball, they would still, all the asteroids in our asteroid belt, they would still be smaller than our moon. Most asteroids orbit our sun, and asteroids have days that depend on the amount of time it takes for them to rotate. More than 150 asteroids have moons, and only one has rings. Well, that's actually kind of weird, because how would they get the ring, right? The only way they could get rings is if they basically destroyed another asteroid. There's no way to do that since they have no atmosphere. And only 10 spacecraft have been launched to explore asteroids, and only one has landed on asteroid 1. Which this also confused me, is how can I barely have any on any other moons, but have 10 going to the asteroids. Now that's all for the asteroid belt. Now let's move on to the comets. Here's our last thing. Yay, it's the last thing. Now, comets are cosmic snowballs, which basically means if you were cosmic sized and they weren't flaming, you would throw them like snow. They would be like snowballs, outside, and they're all of frozen gases, rock, and dust, roughly the size of a small town. Now, before I continue, the reason why comets have this tail and it's so beautifully colored is because of all the gases. The gases are contained in like little bubbles inside the surface, and when they melt, they get colored and become the tail. And also, the tail is also the particles, which give it the solid effect that you see in the sky. Now, they're roughly the size of a small town. When a comet's orbit brings it close to the sun, it heats up and spews dust and gases, like I said, to a giant glowing head larger than most planets. That's probably amazing, what I think. Because if the dwarf planets in the Kuiper belt, as I said, the comets are made there. Also in the Oort cloud, which is not in this presentation, just mentioning it because it's another one of the dwarf planet creators. Now, it stretches, and like the dust and gases form a tail that stretches away from the sun for millions of kilometers. That's a lot of miles, as you can say. Short period comets that orbit the sun in less than 200 years, that may not seem short. That's short in space years. Reside in the icy region known as the Kuiper belt, beyond the orbit of Neptune from about 30 to 55 AU. I don't know what that means. But before we continue, well, I forgot to mention one thing in the asteroids. The asteroids are considered in different classes. A, B, C, D, all the way down to Z. They're in different classes. But you're probably wondering why. They're called classes because each asteroid has different materials. All of them are made from different materials. Like each letter represents a certain material inside the asteroid. And that's why they're put in classes. Now, let me go back here. This is the end of my presentation. I really hope you enjoyed. As I said in the beginning, this was really fun making, and my 6th grade project. And I'm Justin Harrison, Miss Marin's student, and this is the end of my presentation.